Good morning. My name is John King. I'm a professor of oceanography and an associate director of the Coastal Institute at the University of Rhode Island, and I'm here to talk to you this morning about a real-time monitoring network for the south coast of Rhode Island and Narragansett Bay. We're using this network to measure coastal erosion using terrestrial LiDAR, and we're doing it in the context of a sensor network that measures the drivers of coastal erosion: waves, currents, tides, sea level rise, and storm surge. My collaborator on heading up this project team is Nathan Vinatiero, also of the Coastal Institute. The key research questions that we're looking to answer in this project are: what are the rates of coastal erosion and accretion in Rhode Island, and how have they changed over time? What hydrodynamic processes, waves, tides, currents, storms, primarily drive erosion and accretion? How effective are coastal resiliency / coastal restoration projects in Rhode Island? How valid are existing coastal inundation and erosion models, and how can observational data be used to improve these models? And finally, are observations of accelerated erosion primarily the result of storms or sea level rise? The academic disciplines represented by our project team are coastal geology, geophysics and marine remote sensing, coastal engineering, physical oceanography, numerical modeling, and coastal mapping and data collection, and finally, geospatial data visualization and management. We have a rather large project team, including academic institutions, several units at the University of Rhode Island, Eastern Connecticut State University, a state organization, the Rhode Island Coastal Resources Management Council, two Rhode Island municipalities, Charlestown and Narragansett, and non-governmental organizations, the Shelter Harbor Conservation Society and the Narragansett Bay Estuary Program. Our study area is primarily along the south coast of Rhode Island. You can see the area in the red box. This includes the area that we do our terrestrial LiDAR surveys along the south coast, and you can also see locations of sensors, which include tide gauges and current meters. We also extend the terrestrial LiDAR surveys up into Narragansett Bay itself. Our survey approach utilizes terrestrial or side-looking LiDAR that's mounted on a boat to scan along the coast at a cruising speed of a few knots. And we can also have an option of using a sonar to simultaneously measure bathymetry, and the data we acquire can then be used to produce a seamless topobathymetry map continuously along the coast. With this approach, we can survey the entire coast of southern Rhode Island in a day. The rest of our equipment consists of sensors deployed within the field area. These include a number of acoustic Doppler current profilers that also can measure wave height, and some Falmouth Scientific instrument tide gauges. Some of these instruments produce real-time data that's streamed to a website. This figure shows our real-time data feed from one of our tide gauges deployed on Quanaketag Pond, which is a coastal lagoon on the south coast of Rhode Island. You can see that we're recording tidal height and water temperature. We also have a real-time current meter which reports tidal height, water temperature, current speed, and wave height. This figure shows how we process the terrestrial LiDAR data. You can see the point cloud from the raw data in the upper left-hand corner. There's vegetation along a beach in this figure, and we need to remove the vegetation. So the first step is we remove the vegetation, and this removal results in the production of a digital elevation map shown in the lower right-hand corner. This figure shows an example of our data analysis products. This is a comparison of two surveys run along Narragansett Town Beach, which is one of the primo commercial beaches in the state of Rhode Island. And we're actually looking at the annual storm beach cycle. You can see that beach volumes are at a minimum in late spring and are at a maximum in early fall. And on this figure, we're showing the difference between these two annual extremes. Accretion is shown in green and erosion is shown in red. This information is being used by the town to determine how much sand they purchase annually to replenish the beach. During the course of our project, we've done a number of pilot studies to QA/QC our methodology. One of these was a project for the National Science Foundation to monitor the effectiveness of a geoengineering project on Montauk Beach, where geotextile sand containers were used to reinforce the beach. And we monitored this beach over the course of the normal annual cycle and also after major events. You can see the containers are exposed after Tropical Storm Hermione, but it's also noteworthy that for the most part, the containers were not breached. That often happens with these particular types of containers. One of the key successes of our project to date is that we've been able to do the terrestrial LiDAR surveys along the south coast of Rhode Island and overlay them and compare them and determine accretion and erosion. And in contrast, you can see in the figure the locations that are marked along the south coast are areas that we've done traditionally surveying. With the terrestrial LiDAR, we now have very, very high resolution continuous surveys of the entire coast, not just discrete points along the coast. Another key success in our project to date has been our ability to take observational data, including the terrestrial LiDAR data, but also a time series derived from the traditional surveying methods that extends at our discrete sites back to 1963. I believe it's the longest data set of its type in the world. And we use this data to validate models, in this case, the X-Beach model, and then we can use the validated model to simulate the impact of major events, in this case, the 100-year storm on the south coast of Rhode Island. In answer to the question of what expertise are we missing on our project, this kind of distills down to two areas: the management and distribution architecture for big data sets, and also web development expertise for access, visualization, and analysis of data products. I would describe that as a portal. Those are areas where we could use some help, and I know that there's help available in some of the other groups that are presenting today. In terms of the remaining challenges for our program, the primary one is the uncertainty about sustained funding for our ongoing field efforts, for the maintenance of the existing equipment, and we really would like to expand the program up into Narragansett Bay. Essentially it costs significant amount of money, $100,000 to $200,000 a year, to maintain the equipment and maintain the ongoing field efforts. And expanding the monitoring network into Narragansett Bay, each station is probably $100,000 as you add them. Our other challenge is managing existing very large databases. Thank you for your time this morning.